Hello and welcome to lesson 1 of section 2, Into and Higher Computing, Processor Structure. By the end of this lesson, all pupils at Into level should be able to label a computer system in terms of a 5-block diagram, describe the phrase word length, describe the purpose of a processor, and also list and describe the key parts of the processor, namely the control unit, the ALU, and the registers. Pupils at higher level will be able to provide a more detailed description of the purpose of the ALU and the control unit, and describe the purposes of the register, which is there to make permanent copies of our data, and memory. More about this later on. But just to summarise that again, we've got the input devices, which are devices that enter data into the computer, i.e. keyboard and mouse. Output devices, these are devices that generate output from the computer. Memory, the two main types being RAM and ROM, but more on this later on in the section. And backend storage, we require this to store permanent copies of our files. Without this, you would have to re-enter data every single time. So the processor is really the brain of the outfit. It is a piece of the equipment that actually performs the instructions that the machine requires to do. And this can be broken down into 3 main parts: the control unit, the ALU, which is the arithmetic and logic unit, and the control unit. At int2 level, what you need to know is that this controls order of the execution of the instructions and the timing of the instructions. It ensures that things are done in the correct order and at the right time. The arithmetic and logic unit, or ALU, this performs calculations for the processor, and it also carries out the logical decisions. The registers, these are small temporary stores of information. These are actually on the processor itself. They may only store a few bytes of information, but the access time is ridiculously fast as they are actually physically in the processor. They're not external, there's no time delay there. If you ever hear a computer referred to as a 32-bit computer or a 64-bit computer, this is usually referring to what's known as the word length. The word length is the largest binary number that the processor can deal with in a single operation. Most machines these days all have 64-bit processors coupled with a 64-bit operating system. That means it can use more memory. Technically, it can deal with bigger numbers in a single operation, which usually means it should be a more efficient machine. To summarize, the CPU is the heart of the computer. It has 3 main parts: the control unit, the ALU, and the registers. The mnemonic, if you try and remember it as cars, remember that there is more than one register. Now, word length is the length of the biggest binary number that the processor can process in a single operation. And that summarises the int2 content for the first lesson. Higher content structure in a bit more detail. What we notice is that we're going to mention these 3 buses: the control bus, the data bus, and the address bus. Now they basically link the processor and main memory, also peripherals and such as well. But a bus is just a collection of wires which can transmit a signal. Now there are various control lines in the control unit, and they have various functions. The easiest one to describe is the clock control line. This generates a constant pulse measured in megahertz, gigahertz, depending how fast the processor is, and a single operation can be carried out per pulse. Now the reset line. The reset causes a processor to halt whatever it's doing. It will halt the execution of the current instruction, clear all its registers, and the processor returns to its initial state. The interrupt line. This is when some type of external event has happened from a peripheral, from a device, and the processor can use various methods to decide whether to deal with this interrupt or not. If it decides to deal with it, it actually has to stop what it's doing, so halt the execution of the instruction, load the set of instructions to deal with the interrupt, and then go and service that interrupt. However, there is another type of interrupt which is referred to as a non-maskable interrupt. Now this interrupt cannot be ignored. This interrupt has to be dealt with as soon as it can. And the easiest example of this one would be a low power notification, an overheat notification. It has to be dealt with there and then. The ALU's primary role is arithmetic, addition, multiplication, all the normal arithmetic operations. With regards to logic, it will perform operations such as the Boolean operators and, ors, nots, nor, which is another one. ALU uses things such as accumulator. I mean, the accumulator is a register on the processor which actually holds the results of any Some registers are general purpose. They can be referenced by programmers, usually when writing assembly language, which is a little bit beyond the scope of this unit. Some of the registers now, the ones you do need to know about are the memory address register. This is the one that's primarily associated with the address bus. This is used to hold a value representing the address in memory that the processor is referencing, is wanting to either read from or write to. And the memory data register is primarily connected to the data bus, and this is used to hold the data that's being read from or written to memory. More about this in a minute. What you need to know about the data bus is the data bus is used to carry data to and from the processor. It will hold a binary word, again, just from the two, the word being the biggest binary number that the machine can deal with at one time. Present between 32 and 64 bits. Now it is bidirectional. This means it can carry data to the CPU and from the CPU, which leads nicely onto the address bus. The address bus is unidirectional. You have to remember that the address bus only ever points to the location in memory. It doesn't point the other way, it just points in direction. In the fetch execute cycle, there's a set series of steps that have to take place for a processor to execute, to operate, to deal with an instruction. It has to get the address of where the next instruction is going to be. It'll place that on the address bus. It'll activate the read line, and the instruction is transferred to the processor through the data bus, and it's then decoded and executed. Now this would just go around in a constant cycle. However, there's two main sort of set steps that have to be dealt with. One is when the processor is wanting to write to memory. So first of all, the address bus is set up with the address it is to be written to. This would usually live in the memory address register. The data bus is set up with the data that is going to be written to memory, usually in the memory data register. The write control line is activated, and the data on the data bus is then placed in the specific memory location. And there's a small animation to show that, which will be shown next. What you're going to see is a small animation of the memory write operation.
First of all, the address bus is set up with the address it is to be read from. This usually comes from
Obviously, the converse of memory write is the memory read. Now, it is reading data from memory. It uses the following steps. The address bus is set up with the address to be read from. This time, the read control line is activated. The data will travel along the data bus, and it will be placed in the memory data register. And then, if it's an instruction, it will be decoded and executed, or if it's data, it will be then used in some other operation. Well, now is a small animation of a memory read operation.
First of all, the address bus is set up with the address it is to be read from. This usually comes from the memory data register. The read control line is then activated. Then the data bus is then set up with the data that has been read from memory, which is pointed to by the address bus. The data then moves from memory along the data bus into the memory data register, and this instruction would then be decoded and executed.
So, to summarise, the control unit is responsible for the timing and the execution of instructions. There are various control lines: clock, reset, interrupt, non-maskable interrupt. Remember, interrupt can be ignored, but it has to stop what it's doing, load the instruction, and then deal with it. The ALU unit will perform arithmetical and logical decisions, and remember the purpose of some red registers.